Go over this, put pencils down. Alright, so what was one thing that you said about percents? Ronnie?
Fractions can equal percents,
Okay.
or the opposite.
Okay. Alright, and for example, half equals what percent? Half equals what percent? No, 50%. 1/4 equals what percent?
25.
25%. 3/4 equals, pick out 75%, and obviously, let's say 4 out of 4 equals,
100%.
Alright, what else did we write? Camden. Cross multiply. Alright, how many of you guys wrote that percent proportion formula? This one. Okay, so what number goes here? What number goes on top, below? Part. What number goes on the bottom? Troy? Whole. What number goes up above the 100%? And this will work, guys, for 99% of the percent problems if you have to figure it out. Okay, so this is your percent proportion equation. And then as long as you understand that 1/4, half, 3/4, and 4/4 equals those benchmark percents, again, that's information that as long as you know, think about $1, think about out of 100, that kind of thing. You should be okay with your percent questions. Yes, Camden? Tape diagram, okay. And that helps you solve for your percents as well, okay? All right, what else? Go ahead. Double number lines. All right, anything else that we put in there? All right, please make sure if you did not write this, that you have that on your page. And also please make sure if you don't have this, you have this on your page as well. So give me a thumbs up when you have that written down. All right, go ahead, close your notebooks.
Hey everyone, today we're doing a quick review on ratios, rates, and unit rates as requested. We'll go through the definitions of what each term is and a couple real-life examples of ratios, rates, and unit rates.
Go to iPad. You're mouth.
Before we get started, be sure to subscribe to this channel for more math videos and study tips. Don't forget to give this video a thumbs up for good luck. Let's go. So what exactly is a ratio in math? A ratio is a comparison of two quantities. If you look at our first example, which is this group of people, we'll notice that there are more boys than girls. So we can say the ratio of boys to girls is 3 boys to 2 girls. You can write the ratio as 3 to 2, or 3:2, or 3/2. But out loud, you would just say that the ratio of boys to girls in this group is 3 to 2. You can also flip it and say the ratio of girls to boys is 2 to 3. Either way, you're saying the same thing, that there are more boys than girls in this group. If we look at another example, say I'm making this fruit salad and I want to incorporate some strawberries, but I like blueberries better. So I want a higher ratio of blueberries to strawberries. If you see here, I have 1, 2, 3, 4, 5, 6 blueberries and 1, 2, 3 strawberries. So the ratio of blueberries to strawberries is 6 to 3, which can also be written in these different ways. We can also talk about simplifying the ratio, just like how we simplify normal fractions. If you divide both numbers by 3, the ratio of blueberries to strawberries simplifies to 2 to 1. This actually tells you that for every 2 blueberries, you have 1 strawberry. This all sounds super abstract and useless, but in real life, you'll hear ratios used in statistics like you have a 1 in 292 million chance of winning the Powerball lottery, or just in everyday life, for a chocolate chip cookie recipe, your ratio of flour to chocolate chips is 3 to 2, which means for every 3 cups of flour, you use 2 cups of chocolate chips. So then, what are rates? Remember how a ratio is the comparison of two quantities? A rate is actually a specific type of ratio. A rate is also a comparison of two quantities, but with different units. So before we were comparing boys and girls, where the units of both numbers were people or humans, but with rates, the units of the numbers might be different. In the real world, you'll often see rates as it relates to time. For example, you'll hear about miles per hour or kilometers per hour if you're outside of the United States. And this is in the context of speed or driving or traveling. Let's look at if you're on a road trip from Los Angeles, California to San Francisco, California. The distance between these two cities is 360 miles. It'll take you about 6 hours without traffic to get there. So the rate you'll be going is 360 miles per 6 hours. Whenever you hear the word per, this means division. So you can actually write this rate as a fraction where the miles goes on top and the hours go on the bottom. We'll talk about unit rates a little later, and that's where we try to make the number on the bottom equal 1. You'll also commonly see rates that include money. For example, if you're at a store buying one of those huge packs of bottled water, let's say it costs $4 to buy a pack of 32 water bottles. So written as a rate, we have $4 per 32 water bottles, which we can also write as $4 over 32 water bottles. Another real-life example includes heart rate. So, for example, if your heart rate is 60 beats per minute or 60 BPM, that means that your heart actually beats 60 times every minute. If your heart starts beating faster during exercise or if you're anxious, your heart rate might go up to 100 or more beats per minute. I mentioned earlier we're also going to talk about unit rates. As a reminder, a ratio is a comparison of two quantities. A rate is a specific type of ratio, and it's also a comparison of two quantities, but with different units. And now a unit rate is a specific type of rate. It's also a comparison of two quantities with different units, but for a unit rate, its denominator equals 1. If we go back to our previous example of the road trip from LA to San Francisco, our rate was 360 miles per 6 hours. In order to get the unit rate for that trip, we need to make the denominator equal 1. We can do this by dividing both numbers by 6. 300 divided by 6 equals 60, and 6 divided by 6 equals 1, which is exactly what we wanted for our unit rate. So now that our denominator equals 1, we found our unit rate. I often hear this said as 60 miles per hour. So this is how fast you should go on average in order to reach San Francisco in 6 hours. If you drive slower at like 40 miles per hour, it'll take you longer than 6 hours. Obviously, if you drive at a higher rate or a higher speed, like 75 miles per hour, you will get there faster than 6 hours. Of course, you risk getting caught by the cops and you risk your safety, which is not worth it. So don't speed. For our second example, when we were talking about rates, if we wanted to figure out how much the unit rate of each water bottle is, we want to make the denominator equal 1. We can do this by dividing the top and bottom by the denominator, which is 32. I'm using a calculator here, but we will get $0.125 on the top and 1 on the bottom. So our unit rate is $0.125 or 12.5 cents per 1 bottle. This doesn't make practical sense because you can't really have 12.5 cents, but you get an idea of how cheap it is to buy water bottles in bulk. Technically, this means you're paying 12.5 cents per bottle. Just compare that to the price of vending machines where you're paying at least $1 to get one single bottle of water. So now you know what a rip-off vending machines are. Better yet, you can buy a refillable water bottle and fill it for free at a water fountain. I hope you all learned something in this video. Be sure to give it a thumbs up if it did help you out.
Alright, so again, that was just from Friday, just to kind of review, and then you should not be writing anything, put it away now.
Hi, welcome to Math Antics. Now that you know all about fractions from watching all of our fractions videos, it's time to learn about something called percentages. Percentages are super important. Have you ever been in a math class and heard another student ask the teacher, excuse me, teacher, when are we ever going to use this stuff? You know, like in real life? Well, when it comes to percentages, the answer is 100% of the time. Well, all right, maybe not 100% of the time, but a lot. Percentages are used every day to calculate things like, well, how much sales tax you pay when you buy something, how much something costs when it's on sale, how much fiber is in your granola bar, or how much money you can make if you invested in the stock market. That's all real life stuff for sure. So you can see that it's really important to understand percentages and how we use them in math. All right then, are you ready to learn the key to understanding percentages, or percents as they're called for short? Drum roll, please. A percent is a fraction. What? That's right, a percent is a fraction. And since you already know all about fractions, learning about percents is gonna be easy. But a percent isn't just any old fraction. A percent is a special fraction that always has 100 as the bottom number. If it's a percent, then no matter what the top number is, the bottom number will be 100. In fact, because the bottom number of a percent is always 100, we don't even write it. Instead, we use this handy little symbol called a percent sign. Whenever you see this symbol after a number, it means the number is a percent. It's really a fraction with 100 on the bottom, but it's just being written in this more compact form. Like this number 15 here. It's got the percent sign after it, so we read it as 15%. And because a percent is really a fraction that always has 100 as the bottom number, we know that it means the same thing as 15 over 100. Percents make even more sense if you know what the word percent means. The prefix of the word, per, means for each or for every. You know, like if someone said only one cookie per person, and the root word, cent, is Latin for 100. That's why there's 100 cents in a dollar. So percent literally means per 100. And that's why they're shortcuts for writing fractions that have 100 as the bottom number. All right then. So whenever you see a percent like this, you know it can be replaced with or converted to a fraction. Let's look at a few examples so you see the pattern. 3% means 3 over 100. 10% means 10 over 100. 25% means 25 over 100. And 75% means 75 over 100. These are percents, and these are the fractions that they stand for. There's a few other interesting percents that we should take a look at, like this one, 0%. Can you have 0%? Yes, 0% would just mean 0 over 100. It's what we like to call a zero fraction, because its value is just 0. Remember, it's okay to have 0 on the top of a fraction, but not the bottom. All right then, what about 100%? Well, 100% just means 100 over 100. That's what we like to call a whole fraction. The top number is the same as the bottom, so its value is just one whole, or 1. Okay then, 0% is just 0, and 100% is just 1. But what about numbers bigger than 100? Can you have 126%? Yep, it works exactly the same way. 126% just means 126 over 100. And you know from the fractions videos, that's what we call an improper fraction. The top number is bigger than the bottom number, so the fraction's value will be greater than 1. All right, team. I want you to go out there and give me 110% effort in today's game. But coach, it would be improper for us to give 110% effort in today's game. Okay, so now you know the key to percentages, that they're just special fractions that always have 100 as the bottom number. But there's one more thing that I need to tell you about in this video, and that's decimals. Do you remember in the video about fractions and decimals that you can convert any fraction into its decimal value? Sometimes it was kind of tricky converting to a decimal if we had to divide the top number by the bottom number. But other times, like when we had base 10 fractions, it was easy because decimal number places are made for counting base 10 fractions, like tenths, hundredths, and thousands. Well, guess what? Percents are base 10 fractions. They're hundredths because their bottom number is always 100. That means it's really easy to rewrite a percentage as a decimal number. You can do it the same way as we did in the base 10 fractions video. For example, we know that 15% is just 15 over 100, right? That's its fraction form. But it also has the decimal form, 0.15, because this is the hundredths place, and 0.15 means 15 hundredths. So we can rewrite 15% as a fraction, 15 over 100, or as a decimal, 0.15. And now that you know why we can easily convert a percentage to a decimal, let me show you a really simple trick for doing it. First, you start with the number in percent form, like this, 35%. Next, you imagine where the decimal point should be in the number 35. It's not shown, but if it was, it would be right here next to the ones place. Now remember, 35 and 35.0 are the same value. Now that you know where the decimal point is, just move it 2 number places to the left, away from the percent symbol, and draw it in right there. Last of all, once you've moved the decimal point, you erase the percent sign because you don't have a percent anymore. Moving the decimal point 2 places to the left converted it into the decimal value of that percent. Let's try converting a few more percents into their decimal values so you can get the hang of it. For 62%, we move the decimal point 2 places to the left and get 0.62. Remember, we can put an extra 0 in front of the decimal point to be a placeholder and to make the decimal point easier to notice. For 75%, we move the decimal point and get 0.75. For 99%, we move the decimal point to get 0.99. Pretty cool, huh? Okay, but what about 4%? You might wonder how we can move the decimal point 2 places over when our number only has 1 digit. But all we need to do is use a 0 as a placeholder in the number place that's missing. Then, when we move the decimal point 2 places over, we end up with a decimal value of 0.04. Now that makes sense because 4 is in the hundredths place, and 4% is 4 over 100. And in the same way, 1% would just be 0.01. Again, we need that extra zero placeholder. Here's a few more interesting examples. 0% would just be 0.00. And if we have 100% and we move the decimal point 2 places to the left, we end up with 1.00. But 1.00 is the same value as 1. And that's why 100% represents 1 whole. And if we have 142%, we move the decimal point to get 1.42. That's a value greater than 1, which is what we'd expect, because 142% is really an improper fraction, 142 over 100. Its value should be greater than 1. All right, so now you know that a percent is a special fraction that always has 100 as the bottom number. And you know that you can rewrite percents in either their fraction form or their decimal form. 25% is 25 over 100, or 0.25. But keep in mind that you could go the other way too. If someone gives you a fraction with 100 as the bottom number, you can rewrite it in percent form. If you get 12 over 100, you can say that's 12%. And if you get 80 over 100, you can say that's 80%. Or if you get the decimal 0.10, you can say that's 10%. And if you get the decimal 0.38, you can say that's 38%. So that's the key to percentages. They're another way to write fractions and decimals, but there's a lot more to learn about how they're used in math. And we'll learn more about that in the next few videos. But for now, you should be sure that you really understand the basics of percentages by doing the exercises for this section. Thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com. Hi, welcome to Math Antics. In our first video about percents, we learned that a percent is just a special fraction that always has 100 as the bottom number. So that's simple enough, but it brings up a very important question. If a percent
you are going to need to understand the whole fraction to decimal, decimal to percent, that kind of thing. So that is why that was on there. Again, the benchmark decimals, fractions, and percents are going to be the biggest thing that you guys are going to see. All right, go into, I think Monday should be good for you guys to be able to click on that link for the EOG questions. Download this. go ahead and get started. You're doing number 20. You just put them on the desk. You're doing number 27 and 28, and by then I should have it up. Stand up when you have those questions finished. All right, again, stand up when you have those two questions finished, number 27 and number 28. You should be on number 27, which looks like this. If you were doing any other problem than this, you're doing the wrong one. Kaylee, you're on the wrong one. You were on a coordinate grid one, so yeah, you were on the wrong one. Right, so I might, oh, sorry, 27 and 38, sorry. That was my fault. 27, 38. and go over 27, and then we'll move on to 28. So, hands off your iPads, you should be done with at least 27 by now. Already says 75 sixth grade students choose to watch a movie on the last day of school. That is 25% of the sixth grade class. How many total students are in the sixth grade? What's important in the first question? Pencils are down. Hands are off our iPads. Sarah B.
75 sixth grade students.
So 75 sixth grade students. What else is important? Ronnie?
This is 25% of the sixth grade class.
25% of the sixth grade class. And then what's the last thing that's important? Pam?
How many total students are in the sixth grade?
Alright, so how many total students are in the sixth grade? Now, 75 students equals 25%. How do we go about solving this problem? There's a couple different ways you can do it, but what's one way? Mikhail? No, you don't need to cross multiply. Why do you not need to cross multiply? I mean, you can. I'm not saying you can't, but there's a much easier way to solve this problem rather than cross multiplying. No, what's one way?
Multiply 75 by 4.
Why by 4?
Because 25 can go home 4 times.
Right, there are 4 25s in 100, so you can multiply this by 4. You can also do 75 plus 75 plus 75 plus 75 because each one of these are 25%. So did anybody do it either one of these ways? Good Lord. Okay, and then if you want to do your cross multiply and all of that, you can. You would do 75 over x equals 25% of 100. You cross multiply and then you divide. Okay, so multiple different ways to find the answer to this problem. What is our final answer? What is the final answer? The left. 300. So the correct answer is C for this one. Okay? How many of you guys used one of those 3 ways? Okay, if you didn't use one of those 3 ways, would you like to share what you did use? Wyatt, what'd you use?
Oh no, I used the
Then Wyatt, raise your hand. Emma, what'd you use?
I thought it said 25. So I got the wrong answer.
Okay, but did you still use one of those ways?
I multiplied 25 by 4.
Okay, so even though you missed the numbers, you at least used one of the process, which is fine. All right, anybody else want to share a different way that they found their answer? Okay. All right, moving on to 38. All right. So, Sarah earns $400 per week and spends 15% of her earnings on transportation. How much does Sarah spend on transportation each week? All right, what is important in our sentence? What's important in our sentence? Ronnie?
Sarah earns $400 per week
Okay.
and spends 15%.
Okay. What else is important? Kylie?
How much does Sarah spend on transportation each week?
All right. So this one, excuse me, a couple different ways you can do this. You can set it up in your proportion equation, or if you understand, this actually would probably be a calculator active, and I just got the new calculators today that you guys are actually going to be using, so we will start using those tomorrow. But if you understand percents, this percent becomes what decimal? What decimal does that percent become? Emma?
15.
So 1500s. And you can figure that out by crossing this off, moving your decimal 2 places, or you can put it over 100 doesn't really matter. If you understand that, you can do 400 times 1500s and get the same answer. If you want to do it this way, what was our total? Wait, sorry. You can do it that way. I don't care which way you do it. If you haven't solved this question yet, use one of those two ways and solve. Stand up when you have your answer. It's not a dollar sign. You can't do it. So you need to be like, okay, here, look at my phone. Say, actually, there were 2 something in the cup up there that aren't mine, so I don't care if you take them. Go grab. It's one has a white eraser and the other one has a red eraser. Grab it. Y'all, for the love of God, we have 15 days left. Why are we using colored pencils and pens? Why? Okay, well, if you don't have one, son, the same thing I told Troy. Get your hair out of your face so I can actually see. Thank you. Grab the other pencil that is sticking out of that cup up there with. I'm not having this conversation with you right now. Since you can't find it, don't look in your book bag any longer. Do what I said and go get a pencil. Have a seat. When you cross multiply here and then divide by 100, what do you get? When you cross multiply 400 times 15, what do you get? 60? No. When you multiply 400 by 15, 6,000, then you divide it by 100, you end up with 60. When you multiply 400 times 1500ths, you get this, and you move your decimal 2 places in. Your answer to this question should be 60. All right, questions about that question? Which way do you like better? The percent proportion or moving your decimal? Which way do you like better? Lily? Okay? Okay? All right. Delilah? The percent proportion? All right. So go ahead and move to section 3. In section 3, you need to go to number 9. All right. Says Mick bought some compact discs. if sales tax was 6% and the tax on his purchase was $1.68, what was the cost of the compact discs before tax? Alright, so what's important in this question? What's important in this question, Cam?
Sales tax was 6%.
Okay? What else is important in this question? Anybody? Kaya.
The tax on his purchase was $1.68.
Okay? And then what's the last thing that's important? Camden.
What was the cost of the compact disc before tax?
Okay. Now, I'm going to be honest with you. To me, this question is not a very nice question. And the way I solved it is probably really backwards and doesn't make a lot of sense. But I used my answer choices. I went in and I took $10.08 and I multiplied it by 6% and saw if it gave me $1.68. That is the way I solved this problem. You can do your percent proportion. What is it? 6%. We are looking for the whole. We know the part. You can do it this way. Okay? Whichever way you feel most comfortable doing it, I want you to solve it and then stand up when you have your answer. Stand up when you're done. About 20 more seconds. C. So stand up if you picked A. Stand up if you picked B. Okay, stand up if you picked C. Stand up if you picked D. Alright, the correct answer is C. How do you figure this out? So when you multiplied and then you divided by 6, when you multiply $1.68, sorry, totally out of brain fart, times 100, what do you get? Camden? And then you divide this by 6, then what do you get? What'd you get when you did 168 divided by 6? 28. Okay, so again, that's one way you can do it. If you truly understand the percent proportion equation, that's one way. All right, I don't always understand. I'm gonna be honest with you because I'm so old and I just use my calculator for everything. I'm gonna be honest. Like percents, you just punch it into your phone and it legit, you hit the percent thing and it tells you exactly what you need. So if you understand this, you're good to go. Tomorrow, I'm going to show you guys, I'm going to show you guys how to actually use a calculator, use the percent symbol so that you understand that when you're taking the EOG. You can still do the percent proportion equation using the calculator without using the percent symbol. Okay? Number 10, we are going to do together. So this is an oil company drilled several wells. 50 wells or 25% produced oil. What was the total number of wells that were drilled? All right, so what's important in this first sentence? Anything? In the first sentence? Nothing. What's important in the second sentence? Emma? 50 wells or 25%. And then the last sentence, what's important? Ada, what's important in that last sentence? All right, so 50 equals 25%, or 50 over, I don't know, 50 over x equals 25%. Whichever way you want to do it, solve the problem, stand up and have your answer. You should be doing the work in your notebook. Why on earth do I still see children after 7 days of reviewing, doing the work on their iPads? At this point, baby, just finish. We're on the last one. Just finish it. All right, what is one way that you can solve this problem? And, well, let me ask you, what's the answer to this problem? the answer, Lily?
200.
200. All right, so 2 ways you can do this. What's one way? What is one way, Ronnie?
You multiply, you do 50 times 100, you get 5,000. Then you divide it by 25, and you get 200.
Okay. What's another way you can solve this problem? Camden?
You can figure out how many times 25% goes to 100% and multiply that into 5.
Okay, how many times does 25 go into 100? All right. All right. Close your iPads. Now, at the bottom of this, there are a couple things that, again, you're gonna be able to choose from. Now, this problem-solving PowerPoint practice problem, if you do decide to do this, it is it's just a Google slide, and it's just got practice problems in it. So it gives you some information, gives you some examples, and then you're solving all of this in your notebook, okay? Or not in your notebook. There's a sheet of paper, or there's a stack of papers that I gave you guys. The reason I gave you those is because I realized last week, not thinking, when you turn in your papers, or if you turned in your papers, you had to tear them out of your notebook, which means you pulled information from your notebook. So that is my fault. So I want you guys to do it on the sheets of loose leaf paper that I passed out to you. Okay, everything you do today and tomorrow and Wednesday will be on loose leaf sheets of paper. You have to be responsible enough though to keep those papers and not lose them, because those are what you're going to turn in. So if you do decide to do this one, it's just 6 slides. If you want to work with a partner, you can. Okay, that is your choice. The percent task cards, which I believe I put on Kaya's table, they're actually 2 sets. So again, if you're working on those, or you decide to work on those, there's 2 sets. You can work with a partner on those. They look like this. And then ratios, percents, and unit rates. Those are the ones that are on this table right here. You can also work on those with a partner if you want. All right, the versatiles are at this table. Again, you're using the book, you're either doing percents or unit rates. You don't have to do just percents, but if you want to practice unit rates, you can. There are 4. This is independent. And then the teacher table will be obviously back at the table with me. All right, so those are your options today. Now, let's say that 7 people want to do the same task cards. Well, there's 2 sets, so obviously 7 of y'all cannot be at that table. That is why it is linked for you as well if you want to do task cards, but you're not able to sit at that table and do them. Does that make sense? If you're like, I don't think I can work with a partner or work around people because I'm just going to be off task, that is also why all those things are linked, so that you can work independently by yourself if you need to. All right, any questions with what you're doing today? Are you rotating through these stations? No, you're not. Are you picking these stations?
Yes.
Yes, because it says you will be picking the stations that you like to work through at your own pace. Okay, so again, we're trying that this week. If it doesn't work, we'll figure something out and do it next week. Okay? All right, go ahead, get started. I'll be calling some people.